Okay, question 4. You're looking at the cylinder, and we're looking at A part. We have to show that AC is 4A root 3. Look at the radii of that cylinder, and you will see that the radii each are of length 4A. And from that, you can split this kite in half, and you can mark the 30-degree angle and the right angles. So it's a property of a kite that you had to see. I'm just going to redraw this on the next screen. Alright, and marking in your A and C. From that you used your SOHCAHTOA, so tan 30. Opposite over adjacent, rearrange for AC. And they're looking for the exact form, so you don't want to use the decimal form in your tan 30 in your calculator. You may have to draw the special triangles. And you rearrange as required. Concluding sentence. Okay, part B, we're just going to redraw the diagram, marking in the forces. I'm going to ignore the cylinder at this point because it's just going to make our diagram a little bit too messy, and we are looking at what's going on the rod. We're not looking at what's going on in the cylinder. So mark in all of your forces. We have the W, friction, the normal force at the ground, the normal force and the frictional force at the top of the cylinder. Remember, F equals mu R, so in this case at the top it will be T equals root 3 over 3S, and F equals mu R for the bottom. Go ahead, and our steps we're going to do are the same as we've done every question: resolve, resolve, moments. So let's begin. Resolve horizontally. Oh, before you do that, you want to mark in your angles so that it is easier for you to get your horizontal and vertical components, especially if you're having trouble finding those angles. Look for the Z's and the corresponding angles from your rules of parallel lines. Okay, resolve. I'm just going to put the diagram at the bottom for our reference very quickly. Okay, and we do the friction, T cosine of the angle minus sine of 60 degrees. And substitute what you know about T. And this will help eliminate one of our variables. Clean it up, and you get friction is root 3 over 3S. Now resolve vertically. I'm just going to pop the diagram at the bottom again. So it looks like we have the reaction force, the weight, and the resolving of S and T. And it's in equilibrium, so we'll set it equal to 0. Substitute what you know and replace cos 60 and sin 60 with some fractions. Clean it up, and R equals W minus S. Now take moments at A, and the diagram's just going to pop down here below quickly. You take the perpendicular of W times by the distance. You can mark the distances on the diagram as well. And look to which way it's spinning. And in this case it's clockwise. And notice that S is already perpendicular to the rod, so you do not need to resolve it. Look to see which way it's spinning, and of course it's spinning the other way. Set them equal. Cancel out the a's, the root 3, simplify it, and get a final statement. Now let's put all of this together. So we have S equals 3/8 W from the moments, R from the resolving vertically, fill in what you know, the friction from resolving horizontally, and mu is equal to FR over R, and a little bit of algebra, and things cancel, and mu equals root 3 over 5.